Hi guys, welcome to my mathematics video. My name is Peter C. Jr., mathematics instructor at the University of Liberia and your math tutor. In my today's video, I will be looking at matrix algebra, and particularly under matrix algebra, we will be discussing a combination of like three topics. So we will discuss trace of a matrix, we will discuss transpose of a matrix, and we will discuss the product of matrices. So let's get started. We have this example, and this is the third example from these matrices. The first two, you can check our videos and you will see the first two. So this problem says we must find the T arrow of matrix A transpose C. So T arrow means the trace of a matrix, and the trace of a matrix is just the sum of the diagonal of that matrix. So when you find a diagonal matrix, for instance, this is a diagonal matrix. So if you want to find a trace of this matrix, T arrow of B, it's just going to be the sum of this diagonal matrix, the elements of this diagonal matrix, which is like 6 plus 7 plus 1. So that's how we find the trace of a matrix. The trace of this matrix is just 2 plus 3 plus 5. The trace of this matrix is just 2 plus 2. The trace of this matrix is 3 plus minus 1 plus 4. But according to the problem, we were not given matrix A transpose C as a particular matrix, so we need to derive at matrix A transpose C, and it's just very easy. Now we know matrix C to be this matrix, we know matrix A to be this particular matrix, but we do not know matrix A transpose. So the first matrix we need to find is matrix A transpose. So to find matrix A transpose, we told you in previous videos, just interchange the rows and the columns. So this is row 1, so make this row to be a column. So 2 3 2 2, instead of saying 3 2 2 as a row, say 3 2 2 as a column. This second row, 5 minus 1 and 4, make it as a column, so it's 5 minus 1 and 4. And then this one, 2 3 4, so you're making it as a column, 2 3 4. So we've now gotten matrix A transpose. So we just need to find matrix A transpose times matrix C. So matrix A transpose is that 3 5 2 2 minus 1 3 2 4 4 times matrix C. So matrix C is that, so it's 2 minus 2 minus 2 and 9, and then this is 0 3 and 1 is 1 minus 7 and 5. So this matrix should result into, now we told you whenever you multiply two matrices, or before even you multiply two matrices, you should be able to observe their dimensions. Now these two matrices have the same set of dimensions, they are all 3 by 3 matrices, so there's no problem. So these are all equal. So the resultant matrix will have this dimension of the row and the column of these two matrices. So the resultant matrix will just be of this form: A11, A12, A113, A2, column row 2 on 1. Let's say column row 2 now on column 1, and then row 2 on column 2, and then row 2 on column 3, row 3 on column 1, row 3 on column 2, row 3 on column 3. So this is how you're going to multiply. This is a hint that is going to help you to multiply. So in the first area, in that first position, in this first position, we need the sum of the product of how do I call it? Now the sum of the product of, now what I meant is that you have this row and then you have this column. So this is row 1 times column 1. So it's row 1 times column 1, right? So it's 3 times 1, 3 times 2, 3 times 2, 6, 5 times 0, then you add the 8, right? 5 times 0 is 0, and then 2 times 1 is 2. So all of these represent the first element. And then we move to the next one. We're still using the same rule. We're still on the same rule, row 1 times row 2, or we can say row 1 on row 2, on column 2. So row 1 is 3, 5, 2, and then minus 2, 3, and 7. So it's 3 times minus 2 is minus 6. 5 times 3 plus 15. 2 times 7 minus 14. That's the second element. So the sum of this represents the second element. We continue, row 1 times column 1 or column 3. So 3 times 9 is 27, plus 5 times 1 is 5, and then 2 times 5 is 10. So this is the first rule, first element, second element, and third element. We move to row 2. So it's row 2, column 1. So it's row 2 on column 1. So 2 times 2 is 4, minus 1 times that is 0, 3 times 1 is 3. The same column, row 2 on column 2. So it's 2 times minus 2 is minus 4, minus 1 times 3 is minus 3, and then 3 times minus 7 is minus 21. We have row 2 again on column 3. 2 times 9 is 18, minus 1 times 1 is minus 1, 3 times 5 is 15. So we're done with the second rule of our new matrix. We move to the third rule. So in the third row, again, we start row 3 times column 1. Row 3 times column 1. So it's 2 times 2 is 4. 4 times 0 is 0. And then 4 times 1 is 4. Move to the next column, the same rule. 2 times 2 is minus 4. 4 times 3 is 12, and then 4 times 7 is 28. We'll move to the last column. 2 times 9 is 18, 4 times 1 is 4, and then 4 times 5 is 20. So we now need to sum up to get our final answer. So 6 plus 2 is 8. 4 plus 3 is 7, and then 4 plus 4 is 8. And this one, 6 minus 6 plus 15. So if you take 6 from in 15, you're left with 9, positive 9. So it's positive 9, again positive 9. Minus 14, the signs are different, so you're going to subtract this 9 from within in 14. So you are just left with 5. So we have 5. So this would be negative 5. So you have negative 5. And then in the next area you have 7 and let's say 4 and 3 is 7. 7 is negative, so all of them you adding them, so it gives us 28 minus 28. Now this one as well, you take, now you're subtracting, right? This and this you are subtracting. So if you take 10 from in this, you left with 8. You take 2 from in this, you left with 6. So negative 6. Then you have negative 4. So you left with negative 10. And then the next column we have 27 plus 5 is 32. 32 plus 10 is 42. So this is 42. And this one you have 18 minus 1 is 17. So now it's 17 plus this one. So this 10, 20, you have 30, 32. And then 18 plus 20 is 38. 38 plus 4 is now 42. So this is our new matrix. So the trace of this matrix now should be the sum, the trace of matrix A transpose times C should be equal to the sum of 8, 28 plus 42. So we calculate that sum, we get the trace. So 8 from within or in 28, you left with 20 minus 20. So you take 20 from in this 40, in this 42, you still left with 22. So the trace of this matrix is 22. So that's how we find the trace of a matrix. It's very, very easy, not difficult at all. So it's easy for you to understand. So thanks ever so much for watching. See you in the next video.